Hey everybody, it's Mr. Herman, back with another video. This time we're going to work on interior angles of polygons. We're going to deal with first with just regular polygons. Regular polygons are polygons that have equal sides, lengths, and equal angle amounts. So you can see these are kind of like, you're used to seeing like a stop sign. That's kind of like what we could call a regular octagon. It's got 8 sides. They're not always going to be regular, of course, but in this case, for today they are, and for the lesson they are, and then we'll move later in the week, we'll get a little bit tougher with some that aren't regular. So we start with a basic formula for these. All we know is the number of sides, and we know that the sides are all the same length, and we know that the angles are all the same length. But based on that, there is a formula you can use, and I'll use this middle one to show you how it works, kind of. The formula is simple. I'll put it on top here. To find the sum of all the interior angles, when I'm talking about angles interior, I'm talking about these, like this. That's an interior angle, that's one, and they're all the same because this is a regular polygon. So all the same, this one there we go. They're all the same. Same here, they're all the same. 1, 2, 3, 4, 5, 6, 7. So this would be a 7-gon, or I think they call it a septagon. I can't remember the exact name of this one. I should know, but I forgot it. But I think it's called if you don't know it, you just call it a 7-gon. Whatever that is, number of sides, gon. Number of sides, gon. And that's what we're going to name them after. We'll see on the bottom here, same thing. We'll do with some of these too, some bigger ones. So on this first one over here, again, to find all these angles for all these here, you'll do n minus 2 times 180, where n is the number of sides, or the number of angles, because it's the same. So if we took this here and did like, counted these up, we'll start with this one. 1, 2, 3, 4, 5, 6, 7, like we just figured. Maybe it's called a heptagon. That sounds a little bit right too. I'm starting to try to come back to me here. H-E-P-T, heptagon, I think. If you did those 7 sides, it would be 7 minus 2 times 180. And then you have to divide by n again to get just 1. This top part, if I take this like this out of here, it gives me all of these angles. It's a lot. It's going to be big numbers, especially when you got more sides. It's bigger. But then you divide by the number of sides again, which is 7, and it gives you just 1 of these. And that's what we want to find. We want 1 interior angle. So to do this, we're going to put 7 in here. So we're going to go 7 minus 2 times 180. And I just hit divided by 7 then, like that. So let's put that in our calculator. Not the best at showing stuff. Let's see if we can see it there. I think we can see it there. So using the parentheses for it to work, of course, for order of operations. Otherwise, it will multiply before it subtracts. 7 minus 2 times 180 divided by 7. Well, we get a decimal. So when you get a decimal, you round to the nearest tenth. So 128.6. So one of these angles, 128.6 degrees, right here is 128.6 degrees. You can tell it's obtuse. You just can't quite tell exactly what it is. Let's try this one now. I'm going to count these up using these pieces here, starting here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10's a decagon, I believe. So a 10 is a decagon. It's got 10 sides. So we're going to do 10 minus 2 times 180 divided by 10. Now this one's definitely going to end up being it should at least end up being a whole number because of the 8s and whatnot you see. So let's put that one in. Squeeze it up there in the shadow. There we go. 10 minus 2. You can, of course, just put in 8 too if you want. That's fine. Times 180 divided by 10. 144. So we get an integer for that one. So each of these are 144 degrees. You can tell they're bigger than these too. Some of you are probably wondering, why the minus 2? What's going on with that, Herman? Well, it's kind of simple. Let me kind of zoom in a little bit on this one and explain it to you a little bit more. What it's doing is finding out how many triangles there are in here. So if I take one point here and just make triangles from that one point, you have to stay at the one point for this to work. Over to here, over to here, this one here. Remember, each triangle has 180 degrees in it. The sum of the interior angles of a triangle is 180. We did that last week. Maybe 2 weeks ago. I think it was last week, though. So if I take these into account, I have 1, 2, 3, 4, 5 triangles. Well, 5 times 180 is the same as 7 minus 2 times 180. So that's how this process works, is you're basically finding the number of triangles in it. On the last one here, let's go to these now again. I'm going to start at the bottom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I don't remember a 13 gon, so I'm going to call it a 13 gon. I don't remember what it's called, sorry. If I saw it, I'd probably recognize it, but... So we'll do 13 minus 2 times 180 divided by 13. This is most likely going to be a decimal, again, for this one. See if I can get a decent shadow up here somewhere. It's pretty hard to see on this side always. That's not too bad right there. Let's go right there. So we got 13 minus 2 times 180 divided by 13. Again, because there are 11 triangles. Because we have 2 less triangles than there are sides. You get it as a decimal there. So go 152.3 degrees. Remember, these two happen to be approximate. You don't need to use the approximate symbol, but it never hurts. This one's actually equal. Now let's go ahead and do these down here. Looks like Allie's getting a little bit bothered. A little bothered there. Allie, cat's getting kind of loud. Hey, Allie, come on, cut it out. Okay, so we got a regular 20 gon right here. These are both similar in size, but just to show you how these work, it's the same process. You can't see the image, but it still works the same way. You still take 20 minus 2 times 180 divided by 20. Again, this might be an integer because it's got the tens and stuff. Well, let's see, maybe it won't be. So 20 minus 2, I'll just put in the 18. Let's see if we can go right there. So 18, and not put the parentheses in this time, because 20 minus 2 equals 18, times 180 divided by 20. Yeah, no decimal for that one. 162. So each measure, each angle is 162 degrees. Inside that, each interior angle of that regular polygon. This one will be a 19 gon, so we'll do 19. Again, I could do the show the step here, and then just put 17 in the calculator if I want. 180 divided by 19. Fit it up there so you can see it good. So let's go into here. We'll put in 17, because 19 minus 2 is 17, times 180 divided by 19. And that's a decimal, of course. So 161.1, we'll round that to 5. 161.1 degrees. And there we go. Well, thanks for watching. These are going to be a little tougher during the week, but this is the easier ones now. Remember to always just message me if you have a question. I can explain something to you. This is the guided notes, lesson notes. This is something you can print off and follow along with. This is not homework. Homework is separate. These are the lesson notes. Give them a try. You have a great day. We'll see you. Bye-bye.